Hello, Algebra 2. This is a review of your practice test from Chapter 10. So I'll go through each of the problems and go through the solutions. Some of these are really simple, like number 1, this is just a rewrite. So they give you 7 to the negative 4th equals 1 over 24 over 1. And we have to, so what they gave you is something in exponential form, and you have to rewrite it in log form. So for log form, remember your base just kind of drops down and becomes the base on the log, and then the exponent and the answer switch sides around the equal sign, okay? So the 1 over 2401 goes on the other side, and that becomes the argument of your log, and then your exponent becomes your answer. So again, our base drops down, and then the exponent and the answer just switch sides. And so that's going to be answer choice B on your practice test. For number 2, you have an equation to solve. So you have log base 9 of x is 2. And so we can rewrite this in exponential form. And so we have our base is 2, the exponent on that, our base is 9, and then the exponent on that is 2, and then this all equals x. And so that's a simple solve, simple simplify. So 9 squared is 81, and that's x. So our answer here is going to be choice C. Going on to number 3, we have log x equals 1.4, and we have to solve this. So for this problem, we don't see a base on the log, and so when you have no base written, you can assume it's 10. So for this, we can assume we have log base 10 of x is 1.4. And then we can go ahead and rewrite that in exponential form. So our base is 10, the exponent on that is 1.4, and that's going to equal x. And so then in our calculator, we're just going to punch in 10 to the 1.4, and when we do that, we get x is 25.12. So that's our solution there, and that's going to be answer choice B. For number 4, we have a logarithm that we have to rewrite in expanded form. We have log base 2 of xz. So when you have multiplication in your argument, you can expand that with addition. So this is going to become log base 2 of x all by itself plus log base 2 of z all by itself. And that'll be answer choice C. Going on to number 5, we have log base 9 of xz squared all over y cubed, and this is another one that we have to rewrite in expanded form. So we've got multiplication and division here. So anything that's in the top part of our fraction will be part of the addition, or it'll have a positive sign on it, and anything that's in the bottom part of the fraction will be part of the subtraction, and it'll have a negative sign on this. So we can start with that and divide up all of our variables. So I'll have log base 9 of x plus log base 9 of z squared, I made both of those positive, minus log base 9 of y cubed. And so then now what I can do is I can take the exponents on these arguments and kick them to the front, and those become coefficients. So now I have log base 9 of x plus 2 log base 9 of z minus 3 log base 9 of y. And so then this is going to be answer choice C. So going on to number 6, we have to express this as a single logarithm. So I have log base 9 of x to the 4th minus log base 9 of y to the 5th. So when we have subtraction between logs like that, that's going to turn into division, and whatever is on the positive side goes in the top part of your fraction, and whatever is on the negative side goes in the bottom part of your fraction. So this will turn into, we'll still have our log base 9, and then in the top part, we'll have x to the 4th, and then in the bottom part, we'll have y to the 5th. And so this is going to be answer choice D. Going on to number 7, we have log base 8 of 2.02. And so we can evaluate this using the change of base formula. So with the change of base formula, your argument goes with the top log and your base goes with the bottom log. So it's going to look like this. And this will be what you can punch into your calculator. So you'll do log 2.02 divided by log 8. And so how we can punch that into our calculator, you got to be careful with your parentheses and your division sign, is you can punch that in as log 2.02, close the parentheses, and then your division sign, log 8, close the parentheses, and then hit enter. And when you do that, you should get 0.3381. So then for number 7, our answer choice is going to be C. So going on to number 8. For number 8, we have 4 to the negative x is 9, and we have to solve for x. So to do this, we can convert this to log form. This is going to turn into log base 4 of 9 is negative x. And so then we can use our change of base formula, and this will be log 9 over log 4, and that's still negative x. So then if we punch log 9 over log 4 into our calculator, that's going to give us 1.58496, and so that equals negative x. So then x, if we round it and move our negative sign, that's going to be negative 1.5850. And so we'll have answer choice B. For number 9, we have, let's see, log base 6 of x plus log base 6 of 2x minus 3 equals log base 6 of 2. And so for this, we have to solve for x. So we have addition between these logs here. So then that means we can combine the arguments in the logs on the left side. And that addition means that we're going to combine them with multiplication. So you can think about it as though we're taking this x and distributing it across these parentheses here. And so if we do that, we'll get log base 6 of 2x squared minus 3x, and that's going to equal log base 6 of 2. So now you have one log on either side, so you can go ahead and drop your logs, and that'll give you 2x squared minus 3x is 2. And so now we can subtract 2 from both sides, and we'll get 2x squared minus 3x minus 2 is 0. And this is something we can factor with first and last. If I factor this with first and last in my head, I'm going to get 2x plus 1 times x minus 2 is 0. And then I can take each of those factors and split them up. So 2x plus 1 is 0. X minus 2 is 0, and solve these. So subtract 1, 2x is negative 1, divide by 2, x is negative 1/2. And then on the other side, I'll add 2, and x is 2. So if I look back at the original problem, if I take this x equals negative 1/2 and throw it in, that's going to make that argument negative, and it'll also make that argument negative. So x equals negative 1/2 doesn't work. So my only solution is going to be x equals 2, which is going to be answer choice D. So our last problem, number 10. For number 10, we have log base 3 of 6x equals log base 3 of 2 plus log base 3 of x minus 4. And so here we have to solve for x. So the first thing we want to do is combine our logs on the right side. And so this is something, we've got addition between them, so we'll combine them with multiplication. So you can think about it as though we take this 2 and distribute that across the x minus 4. And so we'll have log base 3 of 6x is going to be log base 3 of 2x minus 8. So I just took that 2 and distributed it across those parentheses. So now I have one log on either side of the parentheses, so I can drop my logs, and I'll get 6x equals 2x minus 8, and I'll solve this. So I'll subtract 2x from both sides, and I'll get 4x is negative 8, divide everything by 4, and x is negative 2. Now, if I take this negative 2 and I plug this back into any of my arguments, it'll definitely make that first argument negative, and it'll also make that last argument negative. So for number 10, unfortunately, we have no solution because it doesn't work. And so your answer for number 10 is going to be A. So that's it for the practice test. I hope that helped clarify things, and I hope you feel ready to take the actual test.